Let's explore C++ operator overloading. It involves customizing operators for user-defined types. Operator overloading lets you redefine how operators behave when they're used with your own data types. This means objects of your class can work with familiar operators like plus, minus, multiplication, division, also comparison operators like equals, not equals, less than, greater than, and assignment operators like equal, plus equal, and minus equal. Here's the basic syntax. Within a class, you define a special function using the keyword operator followed by the operator symbol. For example, to overload the plus operator, you'd write a function like this: complex operator plus with complex object passed as argument. This function then defines how the plus operator will work for objects of that class. Inside the function, create a temporary complex object, add the real and imaginary parts, and return the temporary object. There are two main types of operator overloading. One is the member function and another one is the non-member function. Member function overloading is defined inside the class. This example shows how to overload the plus operator as a member function within a vector class. When you use the plus operator with vector objects, this function is called to perform the addition. Non-member function overloading, on the other hand, is defined outside the class, often as a friend function. In this case, the plus operator is overloaded as a non-member function, but it's declared as a friend function of the vector class. This allows it to access the private members of the vector objects. The function takes two vector objects as arguments and returns their sum as a new vector. Let's explore the operators commonly used in operator overloading. These include arithmetic operators such as binary operators like addition, subtraction, multiplication, division, and modulus, as well as unary operators like plus, minus, increment, and decrement. Comparison operators like equality, inequality, less than, less than or equal to, and greater than or equal to are also commonly overloaded. Additionally, assignment operators such as equal, plus equal, minus equal, multiply equal, divide equal, and modulus equal are frequently used. Special operators such as array subscript, function call, member access, address of, dereference, and stream operators are also commonly overloaded. The table contains operator and their description. The first one is array subscript, denoted by square brackets. The second one is function call, denoted by parenthesis. The third one is member access, denoted by a hyphen followed by a greater than sign. The fourth one is address of, denoted by ampersand. The fifth one is dereference, denoted by asterisk. The sixth one is stream operators, denoted by left shift and right shift. Let's look at an example of binary operator overloading. A common use case is complex number addition. This code defines a complex class with real and imaginary parts. The plus operator is overloaded to add two complex numbers together. The expression a plus b is equivalent to a dot operator plus, with b as the argument. Unary operators can also be overloaded. This includes prefix and postfix operators. Here's an example demonstrating how to overload the increment operator, both prefix and postfix, for a counter class. Additionally, unary minus operator can be overloaded. Here's an example demonstrating how to overload the unary minus operator for a three-dimensional vector class. Stream operators can also be overloaded, specifically the output stream operator denoted by two left angle brackets and the input stream operator denoted by two right angle brackets. This example shows how to overload the output stream operator to print the coordinates of a point object to the console. This code demonstrates how to overload the input stream operator to read the coordinates of a point object from an input stream, such as the console. The subscript operator, denoted by square brackets, and the function call operator, denoted by parenthesis, can also be overloaded. This example shows how to overload the subscript operator to access elements of a matrix. This one shows how to overload the function call operator, allowing an object to be called like a function. This is commonly used in function objects, also known as functors. When overloading operators, there are several best practices to keep in mind. Maintain intuitive behavior consistent with built-in types. Implement related operators together such as equality with inequality and addition with plus equals. Return by value for operations creating new objects. Return by reference for assignment operators. Make operators constant when they don't modify the object, and consider performance implications. Avoid changing the expected behavior of operators. Don't overload operators with non-intuitive functionality. Avoid overloading or, and address of operators. Don't create excessive implicit conversions, and don't make operators perform expensive operations without warning. Here's an example of bad practice. Do not compare IDs instead of full equality check while overloading equality operator. In summary, operator overloading allows custom types to work with standard C++ operators, making code more intuitive and readable. Operators can be implemented as member functions or non-member functions, depending on the requirements. Most frequently overloaded operators are plus, minus, equals, not equals, left shift, right shift, array subscript, and function call operators. Follow the best practices for intuitive behavior, implement related operators together, and consider constant correctness and performance. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.